Hello guys, welcome to another episode of Sound Talk Show. Today we are going to do Advent of Code, Day 10, 2023. Okay, let me show you my keyboard. So this is Glove 80. This is Ultimate Hacking Keyboard. And over here is the Svalbard Data Hand, Svalboard. Okay, I have a review on my website and on YouTube. Search it, you'll find it. And let's just begin coding Wolfram language. Okay, stop that. Voice check, videos check. Am I alive? Yes, I'm alive. So coding Wolfram language. I'm using Softlight keys in Emacs. So this is Emacs. This is today's talk show, and the ping window shows all my command call names in Emacs and the keystroke. I'm using Wolfram keyboard. So let us begin. So the Advent of Code, video resolution, whatever. Advent of Code, can you see it? Yes. Okay. Advent of Code, we did last time, year 2023. We did all the way to day 9. So today is day 10, and I heard it's gonna be a bit involved. I heard from Steve. So day 10. Advent of Code, day 10. So let's begin to read the problem, okay? Am I ready? Yes, ready, and coffee at hand. This is coffee and milk and honey, actually maple syrup. Yeah, if you have comments, questions, post it, okay? So day 10, so I'm gonna try to be as fast as I can, okay? I mean, well, I'm not gonna push it, but I'm gonna try to not talk random stuff. Okay, let's see, make sure I'm ready, okay? Day 10, you can read it, and I'm ready to code. Emacs ready, and Wolfram language is here. Okay, before we begin, let me show you the Wolfram language. How do you get it? So Wolfram language is free. Search for Wolfram language in depth, and you can download free from the Wolfram language website, wolfram.com. Download Wolfram engine, and I have a full tutorial here. Okay, let's begin Advent of Code. Okay, so let's see. Copy that, close. Copy that. Today's talk show. Okay, let's begin coding. Okay, day 10, pipe maze. Okay, so let's look at the problem. Pipe maze. Okay, so you use the hang glider to ride the hot air from desert island, blah blah blah. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled hot springs pointing in a seemingly consistent direction. Okay, the landscape here is alien. Even the flowers and trees are made of metal. Okay, scanning the area, you discover that the entire field you are standing on is densely packed with pipes. Okay, a weird place full of pipes. It was hard to tell at first because they are the same metallic silver color as the ground. Okay, the ground is also silver color. You make a quick sketch of all of the surface pipes you can see, your puzzle input. So the puzzle input is all the pipes you can see. The pipes are arranged in a two-dimensional grid of tiles. Okay, it's a tile, maybe a tiling problem. Grid of tiles, okay? 2D tiles. So you got these a vertical pipe. That is a vertical pipe connecting north and south. A dash is a horizontal pipe connecting east and west. L is a 90-degree bend connecting north and east. Makes sense. J is a 90-degree bend connecting north and west. Okay, J. 7 is a 90-degree bend connecting south and west. Okay, so you got all these L symbols basically. F is a 90-degree bending connecting south and east. okay, south and east, okay, F. Period is ground. There is no pipe in this tile, okay, it doesn't connect to anything, okay. And S is the starting position of the animal, okay, whatever that is, starting position. There is a pipe on this tile, but your sketch doesn't show what shape the pipe has, okay. Apparently you have a bunch of tiles in a plane, and the pattern on the tile is connecting neighboring tiles, okay. At most connect two, okay, so north, east, west, north, south, or east, south, or any of the, yeah, you got all the combination of connection, like that, and that, and that, okay. 1, 2, 3, 4, 5, 6. 6 possibilities. Let's see. 1, 2, 3, 4, 5, 6. Indeed. And plus one that connects to nothing. Okay? Based on the acoustics of the animal scurrying, you are confident the pipe that contains the animal is one large continuous loop. Okay? Seems like you need to find the animal. Starting position of the animal. Okay? Oh God, my alarm clock. So for example, here is a square loop of pipe, okay? So here is the, let's see, where is the puzzle input? Okay, so it looks like, so there are some examples. Let's begin to copy it. Okay, copy. Okay, let's start the Wolfram language. Okay, and let's start input. So paste the input. So here is the problem. Let's see. So that's the description. For example, here is the input. One of the input bug, bad, and okay. So so the period is simply used as a blank. Okay, so in this pattern you have basically a square. That's right. It connects a square. So if the animal had entered this loop in the northwest corner from the, okay, from there, the stretch would instead look like this. Okay, what they mean by stretch? I didn't read the problem. I mean, I didn't read the story prelude. Okay, so okay, stretch is basically the starting position, I suppose. Your stretch doesn't show what shape this pipe. Okay, so this is the stretch. Okay, in the above diagram, the S tile is still 90 degrees F bend. Okay, it's just that you don't know. You can tell because how the adjacent pipes connect to it. Oh, okay, so you can tell. So you can infer the S tile by adjacent. Well, I mean the assumption is that all the tiles connect. Okay. Unfortunately, there are also many pipes that aren't connected. Oh, okay, to the loop. So this sketch shows the same loop as above. So here's another example. In this example, oh God, this is shit. Okay, so S is here. S is the starting tile. Okay, so this doesn't connect north, it doesn't connect west, this connect to the right, okay, and it does connect to the south. So connect south and east, but not north and west, okay. So in this example, in the above diagram, you can still figure out which pipes form the main loop. Yes. Okay, because some other tiles, they don't connect. You see, F and 7 connect, 7 and this connect, but not these two, okay? So So you can still figure out which pipes form the main loop. So maybe there's always one loop. They are the ones connected to S. Okay, those pipes connect to what? Those pipes connect to, and so on. Okay, what weird. Every pipe in the main loop connects to its two neighbors, including S, okay, which will have exactly two pieces connecting to it, okay, and which is assumed to connect back to those two pipes. Okay, including S, which will have exactly two pipes connecting to it, okay, and which is assumed to connect back to those two pipes. Okay, it's not too clear, okay, but okay. So here is a sketch that contains a slightly more complex main loop. So we assume there's a main loop, and the main loop will always contain the S tile. So let's look at this one. The S connect. Okay, so S connect to right and bottom. Okay, and this bottom connects here. Okay, so oh god, this is a bit complicated. So what does this J connect to? J connects to the F above. The F connects to the J to the right. Wait, does it? Yes. Okay, so actually the proper way to draw the tile is like, anyway, these letters are a bit visually confusing, okay? So F connects that, and J, okay. So that's one example. Then here's the same example sketch with the extra. Okay, so I'm a bit distracted. Let's see. Well, so anyone is here. 3 people. Okay, say hi. Okay, so let's go back. We want to finish this. Okay, so here's the same example sketch with the extra non-main loop pipe tiles also shown, okay? So there's a main loop, but there's also possibly non-main loop, okay? Oh god, this problem is gonna be hard, I suppose. Okay, so you got this example where this is S, so let's color the S, okay? Let's magnify. Let's color S, okay? Let's say yellow. So in this example, if you want to, okay, so it says in this example there's a main loop, so S, J, F, J, and there's two possibilities. Oh god. No, there's only one possibility. F and 7, then go back here, then go back here, then 7, then down, then that, okay, so this actually forms a simple snake. So what is it saying? Here's a sample. Here's the same example sketch with the extra non-main loop pipe tiles. Okay, what does that mean? So let's see. Let's go here, 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 okay? I don't know what does it mean, non-main loop pipe tiles. So it's the same, it's not the same. Oh, okay, before it uses the dot to hide some tiles. Now in this one, it doesn't, it doesn't use the dot, so it's actually more confusing. Okay, so now let's see. If you want to get out ahead of the animal, you should find the tile in the loop that is farthest from the starting position. Oh, so you want to find a tile in the loop that is farthest, the most far from the starting position. Okay, how do you determine distance? I suppose each tile is one distance. Okay, so you want to find the tile in the loop. Okay, so the problem is find the tile in the loop. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. What? Instead, you need to find a tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way around the loop the animal went. You need to find a tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way around that loop the animal went. Okay? You should find a tile in the loop that is the farthest from the start. Okay, so basically it's the same problem. It just, useless information. So you want to find a tile that is the most far away from the starting tile by number of steps. Okay, so in this case there is an even odd issue. So let's say if the tile is 1 2 3 4, so 1 2 3 4, so let's say the loop is four tiles, then the farthest is that one, of course, simple. Now if the loop is 1 2 3 4 5 6, wait, 1 2, so one, start counting at 1. Okay, 1 2 3 4 5 6, right? And the farthest is that one. So that, what step is that? Okay, so 1 step, 2 steps, 3 steps, right? So the most far tile is half of the number of tiles. But is it possible for the loop to have 7 steps? Let's try. Okay, so 1 2, let's say 1 2 3 4 5 6 7 8. So let's try again. 1 2 3 4 5 6 7 8 9 10 11 12. Okay, it looks like the loop will always have even number of tiles. So you just divide it by 2. So let's see, 1 2 3 4. So okay, so there is like off by 1 issue here. So the easiest way is that you always start counting with 1. So if you move 1 step, you consider that 2 tiles, instead of just 1. So the distance, the farthest away is basically half of number of the tiles. So if the loop has 4 tiles, the most far away tile is 2, half of the total. Now if you want to count steps, then just minus 1. Okay, so instead you need to find the tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way the loop the animal went. So in the first example with the square loop, okay, the most simple kind of, let's count again, 1 2 3 4 5 6 7 8. Okay, so the max distance is 4, and if you want to count steps, is 3. So the most far tile is this one. So step is 1 2, wait, 1, 2, 3, 4. Correct. Okay, so you can count the distance each tile in the loop is from the starting point like this. Okay, so it's repeating my analysis. 0, 1, 2. So 0, 1, 2, 3, 4. What? Oh wait. So how many total? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Right. 8 tiles total. So max is 4. So 1, 2, 3. What? So hold on a second. 1, 2, 3, 4, 5. Wait, this is a bit different from what I thought. So how many total? 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 2 is 4. So 1, 2, 3, 4. Okay, so wait, I was wrong before. Let's say 1, 2, 3, 4. Okay. Oh yeah, I was right. I just said, I explained it wrong. Okay, so the steps is half of the total number of tiles. Okay, so let's continue on. In this example, the farthest point from the start is 4 steps away. That's correct. 1, 2, 3, 4, half of the number of tiles. Here's a more complex loop again. So let's try to count. So start from 0 then. Okay, so 1, 2, wait, let's see. First of all, count total number of tiles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 total count of tiles. So the max steps would be 8, half of that. Let's try that. So one step, 1, 2, 3, 4, 5, 6, 7, 8. Okay, supposedly. Okay, so here are the distance. So here's the solution. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Wait, 6, 7. Yeah, that's right. How many total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. God, I'm confused again. Okay, anyway, I got the idea. So 16. Right, so if you want to count steps, you minus 1. Is that right again? So let's try the square. 1, 2, 3. 1, 2, 3. Yeah, where is the square issue? But anyway, if you have a square, 1, 2, 3, 4. That's total of 4 tiles. 4 divided by 2 is 2. So that means step 1, 2. Okay, step 1, 2. That's right. So the max step is half of the number of tiles. Okay, so now let's try this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 total. So the max number of steps is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here are the distance. Okay, so find the single giant loop starting at S. how many steps along loops does it take to get from the starting position to the point farthest? Okay, so that is the problem. Yeah, we got the problem. So here, we got the problem, finished reading the problem, and that took what? 30 minutes? What the fuck? $13 minutes. Oh, 25 minutes. Okay, reading the problem, 25 minutes. Now let's I'm going correct. Yeah, I'm going yes. So we got the problem down. We understand the problem. Now the next step is to for the toy input, the solution is 8. Right. For this input, this one is an input, toy input. So the toy input is this one. Okay, so this is the sample input. Solution is 8. Okay, that's the answer. So now let's get my puzzle input. Click, copy. Now here is the puzzle input. Let's see. Okay. Let's see. 140 characters. 140 by 140. Okay, not so bad. Now we need to save it. Advent of code. Let's see. Day 10. Okay. Day 10 input. Okay, let's say day 10. Oh, okay. So select all, delete, and copy and paste it. So there it is. Save. Copy the file path. Go back here, and here is the user input. Show in browser. Okay, that's the user input. Now let's have a look. So 140 by 140. So you need to. So first, the problem is that you need to find S. First of all, find S. Yeah. Okay. So there it is. There's a unique S. Start from S. And oh god, this is a problem. Shit, I don't know if I can finish in 1 hour. So you found the S, then this starting position forms a loop. Okay, so you need to go through this maze. You can call it a maze. So you need to start to traverse the maze. You need to examine the left, right, and up, down characters, the neighboring characters. Okay, and you will find 2 tiles that connect to it. Okay, so for example, here is north and south. Okay, then what you do is let's magnify. Okay, that's not so good, too big. Okay, so you find the next. So you find 2 neighbor characters. Then you can pick one. Let's say start from one of them. Then you find the next connecting characters. Okay, right, and you basically repeat this. You repeat this until you are back to S. That's right. It's supposed to be guaranteed. You will return to S. Okay. Now, which direction should you choose first? Does not seem to matter. Okay. So once you reach back to S, you want to count how many characters are there total. Okay, then divide it by 2, and that's your answer. Okay, right. So the heart of the problem is just to traverse this text file. Oh God, this is tough. Yeah, this problem is kind of tough. So the problem is to traverse this text file. Okay. Am I going? Yeah. So the main problem is to traverse this text file. So let's think about how to do. So you get this. So this text file can be represented as a matrix. Okay, there are many. I suppose there are many efficient ways, but let's say it's a matrix. Then it's fairly tedious. Now, do you have a situation where you go into the edge? And no, you don't have that situation because from the context you don't have that situation. So you simply just follow the character. So for each entry in the matrix, you want to find the neighboring entries that is valid, and you can assume there's only one besides the one you came from. So basically, given a matrix, you have 3 other choices and one of them is valid. Okay, then you just go to that one. So each one you found a valid item, you push it into a list. So once you reach your character S again, you are done. Then you count the total number of the tiles. Okay, so that is essentially the algorithm. So, but first of all, you need to find the S entry. Okay, so I think this is well, God, today is the wrong day to do this problem. I'm kind of tired. So, shit. So I'm not sure I can finish this in 1 hour from now. So here is the S. That's right. But can it be? I mean, let's not be pessimistic. I mean, let's look at from an optimism point of view. It's pretty simple. Given a matrix, you want to find the neighbor, so it's easy. Given a matrix, it's easy to. Well, it's not. Well, it's very tedious to get the neighboring entries. Then you just so you have basically 3 other choices, 3 or 4 if you count the original. So you have 4 other possible choices minus the where you came from, so you have 3 other choices. Then you do some kind of condition to find which one is the one. How do you do that? Well, that depends on which one you came from. So, for example, if your current character is 7, oh, that makes it much easier. Oh, wait. Oh, okay. So once you come from a character, you arrived at the tile. There is only one direction, so you don't have to do a condition. The current tile will tell you which one is the next. Oh, so it's so easy. So each tile will point to 4 possible directions. The tile will tell you which way to go. Okay, so you analyze the current tile, it's 7, for example, it's either west or south. You analyze the tile, then each tile will give you 2 directions. The valid one is the one that's not where you came from. Okay, so given a tile, you need to find the next 2 possible choices, which is the column and the row and column index. So a tile will induce you 2 indexes in a matrix. Okay, and you need to pick one of them. You need to pick the one that's not the one you came from. Okay, that's you can do that, yes. And the indexes for the matrix are always unique, of course, column and row and column. Okay, so each tile will give you 2 new indexes. You choose the one that's new. Okay, then you go to next step. Okay, now it's more clear. Let's write it out. So we need to write this out. God. Okay, oh God. So okay, so something like so for example, put the input into a matrix that is array, nested array. Okay, then each array item is a tile. Okay, find the starting tile S. Okay, S is the one. Each array item is a tile, and it is a single character. Okay, find the starting tile S, find its row, find its index, row, and column. Row index and column index. Okay, then given a tile, it gives 2 other matrix indexes the tile connects to. Okay, so let's put that there. That's a prelude information. Okay, so now you begin the algorithm by find the starting tile S, find its index. Okay, a tile is identified by row index and column index. Okay, we can call it ID. Okay, so find the starting tile, find its ID, then find the 2 ID it connect to. Okay, let's say tile. Okay, so find the starting tile, push the ID to a result list. Okay, then find the 2 tiles it connect to, pick the one. Wait, so starting tile S. Okay, starting tile is kind of special. Starting tile S. Okay, God, the starting tile, you need to examine all its neighboring tiles, right? Because you don't know what S is like connecting to. Look at all the neighbor tiles of S. Okay, so well, God, how do you do this? So you look at all the neighbors of S. Well, and you have to take care of edges, something like that. So you look at all the neighbors, east, west, north, south of S. Then you check them one by one to see. Oh, it depends on the tile position too. So for the east tile, you check if it connects to the west. God. Shit. Something. Then you arrive at next tile. Then you do this, okay? Then, that's that. But the beginning is actually harder than... okay, I cannot finish this in 1 hour. Just... we haven't started coding yet. Any comments? Michael, hello. If you need to configure a QMK keyboard, would you use VR software? Yes, absolutely. VR software, okay? VR software is the best user interface, graphical. It's extremely easy to use. I have for QMK. So anyway, I'm not gonna talk about keyboard today. Xiaomi phone, hello, good morning. Focus on the problem, okay? Let's do the algorithm today. Let's talk about this at the end of the code. I don't think I can finish it today because my wife is coming back in an hour, and so this is shit. This doesn't look good. Oh God, this is so. Starting, you find you want to get all the neighbors, okay? So get all the neighbor tiles of S. Then you need to examine each one of them. Why? Because you need to find. So you have 4 neighbors, at most 4 neighbors. Okay. It has 4 neighbors or less when S is on edge, okay, or corner. So that's a special case you need to deal with. So look at each one. Then you need to find. So for the east neighbor, it should be one of these characters, okay? So let's see if we can go back to this humongous file. So 140 is actually not too bad. 140. I mean, yeah, I can finish coding this, but not in an hour. So, but I mean, it's just tedious. There's no, it's not really a hard problem, but it's fairly tedious. So we know what to do now. Basically, we know what to do, and if I have to explain them in detail and write it out, it's gonna take another 20 minutes or 30 minutes. But I know what to do. So now that you know what to do, so for example, you look at each tile in the beginning. for the east tile, only some of the characters are valid. For example, dash is valid because it connects east and west, and J is valid because it also connects to west, and there's another one valid. So for each tile, for the east tile, there are 3 possible valid tiles. So one is dash, one is J, one is like 7, okay? 7J dash on the east side are valid. Okay, similarly, in other directions, you also have 3 possible valid tiles. So you look at all the neighbors, and when it's invalid, you ignore it. When it's valid, the end result will be there will be like 2 valid tiles. Basically, yeah, there will be 2 valid tiles. That's neighbor 2S, okay? Let's write it out. For example, for the east neighbor, 3 possible tiles are valid, okay? They are dash, J, and 7, okay? Similarly, for each direction, you have 3 possible valid chars that makes the tile, the path valid, okay? But in the end, by the assumption of the problem, there should be 2 tiles connected to S. So in other words, you'll find 2 valid tiles that's a neighbor of S. Okay, then you can pick, either one of them and begin traverse. Okay, so the traverse steps is that when you arrive at a tile, find 2 tiles it connect to. Pick the one that's new. Okay. Repeat this until you reach a tile that is S. Back to S. Okay. So that is algorithm. So now we have a complete analysis. Okay. But now let's think about, okay, so, let's show, show this so it's interesting. Okay, so, God. This doesn't matter how you format it. Are there anyone watching this problem? Give me some feedback. Okay, so, okay, so but we got this written down. Basically, that's the steps, okay? Now let's think about possible tricks to make this easier. It's a very tedious problem. Is there some kind of trick that will significantly make this algorithm easier to implement? For example, so is there any dot there? Yeah, there is dots. Dot is basically a wall. So whenever you see dot, you can like eliminate. So for example, you can first of all scan all the elements, all the tiles. Whenever you see a dot, you put that dot's ID, the row index and column index, into a dead end zone. Okay. So whenever you need to check a tile, you check the dead end zone if, a hash table or something. if that, if the neighbor is one of that, already it doesn't, that's not your choice. But if we do this, it's no more efficient than just actually look at each tile. So that is okay. So okay, I don't know if I'm gonna finish, or I don't even know if I'm gonna start coding this. Maybe we'll have to code it tomorrow. And this weekend I'm gonna do. I think I need to, start to do this SVA board, so that. By the way, SVA board, this thing is using QMK. I mean that VIA software. So it's gonna be fantastic fun. So anyway, the problem is, there any shortcuts? Let's think about this. So so we got this tile thing. Is there any kind of like shortcut to start with S? So S is here. So there's 140 by 140. What about if we just start, we just go through each element in the matrix? Does that work out? Is it gonna be easier? I don't think so, because 140 times 140 is a lot to go through. But if you just follow the loop, there's less number of tiles to look at. Is that right? I don't know, but is there some trick? Let's see. Is there some trick? Now, there is a visual trick. If you just turn these characters into Unicode symbols, like I can, for example, let me show you. You see, you can turn this 7 and J into these Unicode characters. Then, so for example, replace 7 by that character. Box drawing heavy down and left, and replace dash. Dash is easy to see. What about J? So replace J by this character, box drawing heavy up and left. Then you will immediately see the loop. Let's see, if we follow this, let's see, we can try to follow. Let's go up that. So one. So counting S, okay, 1, 2, 3, 4. Wait, what? 1, 2, 3, 4, 5, 6, 7, 8. Well, God, tricky. 9, 10, 11, 12, 13, 14. Tricky. Look at this. Yeah, so you can see. Yeah, but can we easily see the pattern? No, not really. Yeah, but if we replace all these characters by the Unicode, we can easily see it. Shall we do it? Yeah, that's excursion. That's not solving the problem, but it is fun to do. So we can actually see the pattern. Why not do that? Okay, is there any opinions? There's no comment. Okay. Okay, so okay, so that's one thing we can do. But so that's one thing we can do. Okay, but anyway, you got this loop. You got this loop, and so what's some other tricks we could use? So these tiles, this maze, so we know for sure there is one loop, okay, that connects to S. There is one loop that connects to S. Now basically the problem is asking you to identify this loop. So is there some kind of like carpet sweeping way to identify this loop? Identifying this loop just means you find all the indexes, in a matrix. So is there some kind of sweeping way instead of we traverse each one by one? Okay. Yeah. Well, you go row by row, and you can, for example, let's say identify all the vertical lines. Those entries connect to the following, but not if they are not. For example, here they don't. So if you look at them row by row, then you know if the tile is like anything horizontal, then that's invalid. Okay. Well, not necessarily, because it's invalid going down, but it may be valid going side to side. So you can have like go inside and then go down. So God. So again, you need to identify this loop, this path in this matrix. Is there some simple way you could? Okay, we know the loop connects to S. So far it appears the easiest is actually just starting from S. So we start from S and we traverse. How difficult is it? Because you have to find all the neighboring indexes, then extract them from the matrix. So potentially you have to do hundreds or tens of row and column extractions, extract the element. And you have to do them so much, so frequent. Okay. So that is not. Can we write an AI algorithm to do this? Yeah, but we need a lot of training data. That's right. And it's not likely to be 100% solution. Yeah, this would be interesting as a machine learning thing. But yeah, but that doesn't give us faster solution, because then you get into the problem of creating this maze. You need to create millions of them, which is indeed an interesting thing to do, to write a artificial machine learning solution for this. But it's gonna take you many hours. Okay, 10 hours at least, more than 10. Then because then you need to deal with the neural net. Yeah, that's and I'm not experienced in that. But you can feed it to Wolfram language. Just feed it, lots of input. Yeah, but anyway, that's not a practical solution to solve this problem at hand. So it looks like you just have to traverse each from S. Okay, so today's live stream is just analyzing this problem. Okay, then we're gonna shut down. Maybe a silly idea, but what if you replaced each char with a function to go in a direction? Then you just execute the symbol at each location. Oh, that's interesting. I missed the beginning thought, so I only get what you are doing. So that's an interesting thought. Thank you. So you replace each char with a function. Oh, that's interesting. Yeah, that's can be doable. So when you want to examine a tile, instead of doing if statement, for example, on the east side of a eastern neighbor, you have to do a if statement. If that tile is certain character, then it's valid, otherwise no. And 3 possible characters are valid for each neighbor in a particular direction. For each direction, the possible valid tile is different. So you have to have some kind of table lookup too. So first of all, you have like eastern neighbor. Okay, so for eastern neighbor, these 3 characters are valid. For western neighbor, then another set of 3 characters are valid, right? Then eventually you determine there are 2 neighbors that's valid path, right? So from your suggestion is that once you encounter a tile, you have a table too. You map the tile character to a function. Then the function will tell you which direction to go. So what the function does is just basically push. Traverse the tile just means push the the valid tile to the result. So I'm not sure that. That just translates to the actual code. So I don't know if that. Is it? Can we do something? I don't know. So the tile. Each character in a tile can represent a function. So for example, f just means going. So if you get a f, what does it do exactly, this function? The function will return east and south, I suppose. So if you pass the function an argument that is a current tile position, then it can return the matrix ID, the index that the tile connect to. So for example, it will return that row and column, and it will return that row and column. Right, so each letter can represent a function. Okay, the function, so each letter basically returns east, west, or two of the directions. Then if you feed the letter combined with a coordinate, then it can return two coordinates. Right, something like that. Yeah, but that's that would be part of actually writing the code. But does it somehow help you in a higher level sense skip some steps? I think maybe that does in the implementation part. Yeah, I don't know how to. So far, that's an interesting idea. Okay, so that reminds me, instead of doing if statement check or switch or conditional, you can use pattern matching. So because Wolfram language is good for pattern matching, so you can have similar to this idea function. So let's say L. So what you're gonna do with pattern matching? So let's try. So so let's write a function. Let's say go something. I'm just making this up. I don't know how it will work. So if you have a go to something like that. So if the function is given an argument L and row index, okay, and then something like column index. So the function is given. So if that, so for example, we can define a pattern matching. So whenever we see this thing, it becomes, then it returns two more indexes, something like that. Meaning those two indexes are the valid something like that. So instead of saying index, let's just say coordinate. Make it simple. Coordinate means a row and column index. So if you see that, so if you see a string L with a particular coordinate, then you get two new, okay, so not just two, but so sometimes you are at the corner or edge, but at most you got two new valid coordinate. So, but sometimes one. Or just one of them. but something like that, or just one of them, yeah, but how okay, so right now I'm doing nothing. I'm just trying to avoid actual coding of this problem. I don't think I'm gonna do it. Yeah, but okay, so let's just go with this fantasy. So let's say, so if a pattern, can we, yeah, can we somehow make some kind of like magical sweep that just get the answer, some kind of magical pattern matching or something? This is related, I believe, to the day 3 in 2003. There is a problem. Advent of a code. Day 3, yeah, there's a day 3, which is kind of similar. You got a two-dimensional text that forms some kind of pattern, and you need to get the neighboring numbers. Okay, so this is Advent of Code 2023, day 3. And I spent a week. So you look at the code, this is complex. I spent a week on this because I was trying to find some kind of like a magical solution that can see the whole pattern, but eventually I cannot do it. Yeah, eventually I can't do it, so I end up with this solution. Yeah, actually it's this solution. So we have a similar situation here. Is it possible to have a pattern somehow? I don't know. So what about this idea? Well, this is actually just coding. I mean, this is actually this is not something meta level. This is actually just dealing with, this is just actually using patterns instead of using if statements. But for example, this actually return north and south. Okay. So if you have L, it basically means that. But if you with L with coordinate, for example, we can write it like that, then it gives you coordinates. Okay. So this is kind of nest, currying. Anyway, but so we can start to write this pattern. For example, dash. Actually, this you don't need that. And coordinate. And actually, we can start to code this now. So this coordinate will be, actually the coordinate is easier to write row, column, okay, index. So row and column are indexes. So once you see that, then you just get two possible So once you see that, you get row plus 1. Okay, so row plus 1. Wait, row stays the same. Column plus 1. Okay, that's one coordinate. Then the other coordinate is row minus 1. Okay, so row minus 1 and column remain the same. So that's going north. And this is provided that your row and column is not on the edge, because otherwise, because you don't have a toroidal plane. But actually, we don't have to worry about this, because if we are following, if we are following S, if we are following the path from S, then we won't have a problem of going beyond the realm, like hitting a wall on the edge of the matrix. So then this code is actually valid. So whenever you see L, let's say tile, so not go to. Okay, something like that. So now this is becoming more valid code. So when you see a L, tile L, so when you see tile L, it basically returns south and north. And so what about the order? Should we have a canonical order of the east, west, south, north? Yes, let's go counterclockwise. So north first, then south. So in here it should be in this order, north first. So north is row minus 1, then column remains the same. That's right. So this is valid code, but what you're gonna do with this? Okay, so so we don't care about that. So that's kind of valid code, and let's give it another example. Let's say tile dash. So tile dash is east and west. So east first. Okay, then but then if you give it coordinate, then row plus 1. Row doesn't change. East, so column plus 1. So column plus 1. Then west equals to column minus 1. That's right. So this is kind of valid code, but I'm not sure how it actually applies. So we kind of actually started to code this. So we have to do this for all the possible characters. Possible characters are dash, vertical line. So actually it's easier if we draw it. If we start to draw this, it becomes easier to do. We don't want those we don't want. Those are the same. So that we don't want. We don't want monsters. monsters. Okay, so all the possible, so we already have that. You see, so we can see all the possible characters. So how many possible? 1, 2, 3, 4, 5, 6. Let's see. 1, 2, 3, 4, 5, 6. Yeah. So there's there's 6 possible. 6 possible characters, excluding the dot. Okay, the dot is the dead end. So for the path, there are 6 possible characters. So we can write it f. So this would be f. This would be dash. This would be vertical line. This would be vertical line. This would be what is this? Seven. Okay, so this is 7. This is L, I think. L. And what is this? This is J. Okay, so these are the possible. Okay, so actually now we can write them out. So yeah, now it's clear that vertical line dash vertical line F7LJ. 1, 2, 3, 4. Yeah, 6 possible characters. Okay. So now we have like 2 possibility. Yeah, but we are not doing, this is just if condition basically. We are, so this they are using pattern matching, but it's basically just doing if statement, in a different way. But it does not actually somehow make the problem super easy. Yeah, I don't know. So I'm thinking of stop here today. So what you guys are saying, I was thinking, so like L would execute the function at the coordinate. So it would become sort of recursive B-tree style problem. Okay. Thank you. Ringo Tingo says, hey Xi, just wanted to say you inspire me to learn and keep coding. Really appreciate your work. Thank you. Yeah, coding is, if you are into coding, I'm into coding. Many people are not, but if they are not, they do other things that they are, good at. But if you are interested in coding is, I would say one of the things that makes a lot of money, relatively compared to other jobs. You can make a lot of money, just coding. As compared to, you make, I would say, reasonable. It's like like a lawyer or a doctor. And coding has a bright future. It's not going to go away. A lot of people say, oh, AI is going to kill coding. No, actually not. AI is going to increase the value of coders. Okay. There are many programmers, they will say, oh, AI is going to kill coding. Actually that's completely bullshit. They don't know what they're talking about. I'm starting to rant because I'm not doing this problem, so it's easier for me to just say my opinions. So, but that's my opinion. Coding is, it's gonna be more and more valuable, okay, than anything else. So anyway, So as far as this problem goes, we have analyzed it and we kind of know what to do, but the devil is in the details. You have to actually code it, instead of, so only when you actually have a program and it runs, then you can say we got it. Yeah, but I don't have it, and I'm not gonna code it because it's going to take more than 1 hour, for sure. So let's, I think maybe that's it for today. Just random chat. Give him money. Yes, money. Okay, anything else? I think I'm gonna close. So maybe we'll do this continue tomorrow. Is Steve here? Yeah, I'm gonna go have dinner in 30 minutes. How many people? 9 people. What are you guys doing? Well, since we are doing nothing, I can actually just code, just so so there are a total of 6 possible characters. We can finish this. I mean, yeah, but what does that give us? Not too far. So, and first of all, we have to search for S. Well, first of all, you need to turn this input into a matrix. Now, there are several ways. Either you turn it into a matrix, then you refer to each item by a row index and column index, or you can kind of take the whole thing as a string, then you have to refer each item by some kind of accumulated index, Either way, both way are more, it's like tedious, like like the number 3 day 3 problem we did before. Where is it? Yeah, this available code day 3. So what did I do? Did I do a string position? Yeah, I didn't turn it into a matrix, but so with a string, then you have to consider the efficiency. Actually, we are not worried about efficiency because you have to consider the efficiency of extracting from string versus extracting from a 2D matrix, because you need to do that a lot, like hundreds times. But that's not our concern. Our concern is actually find some kind of higher level algorithm for this problem. And so far, it doesn't, I don't have any ideas. And this idea about using a function to so each character is a function, then recursive I would execute the function at the coordinate. Okay, so what does the function do? So it would become sort of a recursive B tree. Okay, so I would execute a function. Okay, so I mean, if that's if we're gonna do that, then this function will be named goTo, and it will actually return. It will just return one single tile, one single coordinate. Okay, something like return a coordinate, which is a valid path. But then this goTo, you will need, let's put it here. you will need to also feed it the current tile. That's right, the current tile. Okay, so you need it. We so I think we actually just have to code it instead of talking abstractly, because in order to do that, what does the function? I mean, does the function takes input? If the input is L, it can do much. If the input is L, it just return north and south. That's the maximum it can do. It also needs the current coordinate. So the function will need arguments. The current coordinate and the new tile coordinate, and right. So it needs the current coordinate, the current tile. Yeah, well, so you see, it gets complex. You see, you can't just function represent L represent the function, because in order for the function to actually do something useful, such as return the next valid tile, that function needs the current coordinate, right? And it needs, right, so if that function needs a current coordinate, then that function can represent L. So I mean, we have to work this out. So yeah, to actually code and see what I think. Yeah, I think so. So what are we doing? So first of all, represent. We are kind of start coding. We can't do nothing without actual coding it. So actually, we can start with the toy input. So the toy input is where is it? So the toy input is that. Okay, then we start to find. So the first question is, do you want to turn this into a matrix or not? If you want to turn it into a matrix, you just do a split on new line. Then for each line, you do another split by an empty string. Then you get a matrix. Now, if you don't want to do it in a matrix, then you just then it's more tedious. Then I mean, it's not intuitive, because then you use basically modular arithmetics. You have to determine how many lines are there. Each index, the index become total number of characters. So which can be turned into line number and column number. Yeah, but but every time you get a new index, you have to do this step of turning it into a line number and column number. So that's not intuitive. So the more intuitive is just start to string split. Yeah, but then it's just starting to become tedious coding. Okay, string input, then split. Yeah, okay, so but suppose we got a matrix. Then once you got a matrix, then go through what? Oh, okay. Go through matrix, find coordinate of S. Okay, then you push S to a result path. So we define a path. This path will be empty list, and each item is a string. Okay, something like that. I mean, it's a character. Wait, is it character or wait? It should be each item is a coordinate. Okay. Yeah. Then you run into a problem. Then it's then you need to find all the neighboring coordinates, neighboring tiles, their coordinate. Then for each coordinate, you have to find what letter it is. Then for each letter, you need to check its valid over there. Yeah. So, okay. Okay, I'm gonna chicken out. I'm gonna shut down. Because I cannot finish it. It's gonna take another hour. So that's it for today. We shut down in 3 minutes. We already spent almost like two hours. Chicken out. Chicken out, which is a bad thing to do. Okay, we shut down in 3 minutes. Advent of code, tedious problem. Advent of code. Let's search. Let's see who did advent of code. Usually day 10, not many people do it. Now I will finish this for sure. Just not today. Tomorrow, yeah, tomorrow maybe. If I'm not busy tomorrow, I will solve this. Either this or I'm gonna start to do the Sval board because I really need to get on it. I'm gonna plug in and just live stream it. Then that's first step. Then once you start to do something, you will start to do it. So day 10, you need to advent of code. Advent of code. Day 10. Let's see what other people. Oh, there it is. Look, advent of code on Reddit 2023 day 10 solutions. Okay. Here is a. What is this? Ruby or Python? Open.read.splitlines. That's Ruby. I think that's Ruby solution. Oh, this guy is fast. Jesus. So here is the open input read split lines. Okay, so it's split lines and dictionary zip. Wait, this is Python, I think. So zip. So and something TC 1 plus J 3. There's a lot of smart people out there. Yeah, quite a few solutions. Okay, bye guys. Elixir program. Okay, now I'm curious. I never searched. Is there a Wolfram language solution? I never searched. Advent of code solution in Wolfram language. What year is this? 2021. Oh, let's see. This is from the Wolfram people. Oh, okay, not an employee, but Numerical solution in the Wolfram language 2021. Now, what problem does it solve? Does it solve just one problem or what? Numerical solutions in the Wolfram language. Oh, it's got a bunch of problems. Say 1, 2, 3, 4. Okay, but this is 2021. Oh, wait, this is 2020 advent of code. Now, 2020, I don't think I start to do it. Let's see. Announcing winner of one-liner. Announcing the winners of the 2023 one-liner and get visual competitions. Yeah, okay, so I don't think there is. So this is Advent of Code 2020. Do we have something more recent? Advent of Code 2021 solutions. Okay. Who is solving Advent Code 2000? There it is, Advent Code 2023. Online technical discussion groups. Should we cheat and look at their answer? Okay, Samuel, there's a lot, these people are smart people. Let's see. Let's turn on JavaScript. Advent Code 2023, Day 1, Part 2. Oh, he's got it all. Let's see. Day 2, Part 2. Day 3. Oh, he solved it all. Now, I'm excited to compare my solution to his solution. This is, because in the same language, then you can see which code is more efficient and shorter. Oh, look at, okay, day 4. Let's quickly look at day 10. Okay, day 6, part 2. Day 8, part 1. Day 9. Day 10. Wow. This is the best solution for our problem. So day 10, so he defined north, south, okay, coordinate, okay. That's the addition. So you add that to go into that direction. Pipe encoding. Wow, pipe encoding. Oh. And then original input. So that's the input, original array pad. Okay, so he creates a pad. So he turns it into a matrix, and he also padded it so that you don't get into the edge, problem. And start position, first position, original S, 4057, execute movement, and get pipe, and then length -1, 2. Okay, fantastic. Okay, that's it. That's a solution. Wait, can we copy the code? Does it work? Yeah, let's just do it. Why not? Let's run his code. So copy it. Let's see. Let's forget about our code. Okay, so we didn't do it. That's okay. Oh God. So wait. Okay, this is problematic. Yeah, we don't want that. So can we copy the whole thing? Copy. Let's go to Wolfram language. Paste there. There it is. Okay. Now that's his code. Part 1. Let's run it and see what he. It worked. 7086. That's his solution for his input. Okay, so great. Okay, that's it for us. So who is this guy? Oh, he actually generated a part 2, method 1. He generated a graph for it. Fantastic, amazing. Wow, this is really good. So this guy, I can really trust. So he, for part 2, he actually offered 2 solutions. So then there's day 11, day 12. Oh my God, day 13. So who is this post? Does anyone? Day 21. Wow. Okay, bye guys. Let's go. I want to check Samuel Martino posted 5 months ago. Let's check. I gotta watch this guy. This guy is good. In Quebec, Canada. Okay, he's got a website. Okay, bye guys.